Well, this is a quite an interesting little problem that you find on page 503 in your textbook. It gives us an example of using similar triangles to solve problems. And you see it first worked out there in the book where this Liliana is holding out her thumb. Thumb. Where's the thumb on the kid? Oops, thumb. There you go, thumb. Holding out her thumb in front of her, and she's looking at a car, closes one eye, and the cars shift to the, when she closes her left eye, I think it shifts to the right. If she closes her right eye, the image of the cars shift to the left. And you can see that worked out in that case there in your book on 503. And then it kind of continues on with another example with Liliana. And we'll read that here. It says, Liliana holds her arms straight and her thumb pointing up at the back of the classroom and sights a clock on the wall in the front of the room. Closing one eye, she aligns on the edge of her thumb with the clock she is sighting. Next, she switches eyes without moving her head or her arm. Liliana's arm is about 10 times longer than the distance between her eyes. If the clock is 30 centimeters wide and appears to move 3 clock widths when she switches eyes, estimate the distance from Liliana's thumb to the clock. And so let's look at this thing sketched out, and then we'll solve this problem. So here we have a diagram, and here is Liliana's thumb. And we're told that the distance between her eyes and her thumb is 10 times greater than the distance between her eyes. And we got 2 eyeballs sitting down here. That's kind of interesting. And then here, let's say, is the clock at the front of the classroom. And we're told that this clock is 30 centimeters wide. And then as she switches eyes back and forth, this clock then appears to move 3 clock widths. Now, we're asked to find out how far is the distance from her thumb to the wall. Well, now we're told here that the distance from her thumb extended and the distance between her eyes is 10 times, or we got a ratio here of 10 to 1. And if this clock is 30 centimeters wide and it shifts 3 clock widths, well then 3 times 30 is 90. It would seem to shift 90 centimeters. And so then we're asked to find what this distance is here. So we have a ratio of 10 to 1 over here on the left. And then we could set up a similar ratio here of x over 90 centimeters is the distance from this altitude to where it shifts over. This distance right here then would be 90 centimeters. And all we got to do then to solve this problem is to execute this, do cross multiplication on this ratio. So let's see, we got 1 times x equals x, and that's going to equal 10 times 90, which is 900 centimeters. And if we wanted to reduce that down to meters, we can just divide that by 100. And we've got 9 meters. And let's see, I think a meter is 3.3 feet. So a little greater than 27 feet. Maybe almost 28 feet. All right, that's kind of an interesting little problem. Using similar triangles to solve problems. Got to do some thinking on that one. I like thinking.